The storm already has a name, and the name is Arthur. As of this morning, the National Hurricane Center has confirmed the formation of Tropical Storm Arthur, the first named storm of the 2026 Atlantic hurricane season. It developed off the Texas coast just hours ago. Maximum sustained winds are 45 miles per hour. The center was sitting approximately 40 miles east-northeast of Port O'Connor, Texas at the latest advisory, roughly 165 miles west-southwest of Lake Charles, Louisiana. It is moving northeast at 9 miles per hour. And before you focus on the wind speed, I need to stop you right there, because the wind is not the threat that should be keeping you up at night. Not even close. The threat is the rain. The threat is what happens when a slow-moving, moisture-loaded tropical system collides head-on with a stalled frontal boundary and dumps multiple weeks' worth of rainfall on already saturated ground across the Gulf Coast states. The National Hurricane Center director said it clearly in this morning's briefing. The main danger from Arthur is a prolonged, multi-day heavy rainfall event that could produce dangerous to life-threatening flash flooding across a massive stretch of the southeastern United States. In this video, I am going to break down exactly who is in the crosshairs and what the timing looks like hour by hour. I am going to walk you through the 7-day forecast as the broader pattern evolves, and I will explain what El Nino is doing to shape both this event and the rest of summer. And in the final segment, I am going to give you the full Atlantic hurricane season picture and tell you why, despite a below-normal forecast, the words "one storm can change everything" have never been more relevant. Stay with me. Every part of this matters. I am Arthur, your host here at Sky Space Lab. If this is your first time with us, welcome to the channel. We track real data from verified sources: the Storm Prediction Center, the National Weather Service, the National Hurricane Center, NOAA's Climate Prediction Center, and the European and GFS model ensembles. No hype, no guessing. Just the best information available, explained in a way that actually helps you make decisions for your area. Subscribe right now because this season is already moving faster than many forecasters expected, and you're going to want daily updates here. Let us get into the data. Here is exactly where things stand as of this morning, Wednesday, June 17th. Tropical Storm Arthur is the first named storm of the 2026 Atlantic hurricane season. That fact alone is significant, because climatologically speaking, the average date for the first named Atlantic storm is around June 20th. We are 3 days ahead of schedule. Arthur formed not from a classic Cape Verde tropical wave or a Caribbean disturbance. Its origins trace back directly to Tropical Storm Christina in the eastern Pacific. Christina's remnant moisture crossed Central America, a pathway that multiple models had advertised up to 2 weeks ago, entered the Bay of Campeche, and reorganized as it interacted with a stalled frontal boundary draped along the Texas coast. On June 16th, the National Hurricane Center began issuing advisories on what they designated potential Tropical Cyclone 1. By this morning, Hurricane Hunter aircraft from the Air Force Reserve confirmed that maximum sustained winds had reached 40 miles per hour, and continued tightening to 45 miles per hour by late morning advisories. Arthur is not expected to intensify significantly before landfall. The National Hurricane Center forecasts the center to move inland over southwestern Louisiana by tonight, Wednesday night, and then dissipate by early Thursday morning. The storm's wind field is relatively compact. The tropical storm warning zone runs from Sargent, Texas to Morgan City, Louisiana. A tropical storm watch extends from Sargent south to High Island. Gusts of up to 50 miles per hour are possible along the immediate upper Texas coast and southwest Louisiana through this afternoon and evening. But here is the detail that separates this storm from a typical low-end tropical storm. This is a rainfall event, a generational rainfall event for some communities, and the impacts will outlast the storm itself by days. The latest National Hurricane Center projections call for 5 to 10 inches of rainfall through early Friday across the affected region, with isolated bullseye totals approaching 20 inches. That number needs context. 20 inches of rain fell on some Houston neighborhoods during Hurricane Harvey in 2017 over the course of 4 days. We are not forecasting Harvey-level catastrophe here. But the combination of training rainfall bands, saturated soil, and a stalled boundary means localized amounts in the most vulnerable corridors could reach genuinely extreme levels. Parts of eastern Texas, southern Louisiana, and Mississippi had already received more than a month's worth of rainfall in the 3 days before Arthur even had a name. The National Weather Service had logged nearly 150 flood reports across the region since Sunday alone. At least 2 fatalities have been confirmed in Texas this week from flood-related incidents. So who needs to be paying the closest attention right now? The highest risk corridor for life-threatening flash flooding runs from the upper Texas coast, including Galveston, Houston, Freeport, Beaumont and Port Arthur, northeast through Lake Charles and into Baton Rouge and New Orleans in Louisiana. From there, the threat extends east through Gulfport and Biloxi in Mississippi, through Mobile in Alabama, and into the western Florida panhandle including Pensacola. The flood watches stretch all the way to Atlanta, Georgia. The AccuWeather threat map identifies the stretch from southern Louisiana through southwestern Mississippi and southwestern Alabama as the zone with the most pronounced risks to life and property through Friday. Around Baton Rouge and through the southern half of Mississippi, some areas may receive 2 to 4 inches of rainfall per hour in the most intense training bands. That is a rate that overwhelms essentially every drainage system in the region. If that rate persists for even 2 to 3 hours over the same location, which is exactly what happens when storms train, meaning they repeatedly develop and move over the same path like cars on a highway, you can accumulate catastrophic totals in a matter of hours. There is also a coastal storm surge threat. Between Port Bolivar, Texas and Morgan City, Louisiana, storm surge of 2 to 4 feet is expected above normal tide levels. Surge combined with high tide will push water into normally dry areas along the coast. Swells generated by Arthur will create life-threatening surf and rip current conditions along the northwestern Gulf Coast for the next several days. And one more immediate hazard: isolated tornadoes. As Arthur's tropical moisture collides with the approaching frontal boundary, the low-level wind shear increases and brief spin-ups become possible in the coastal bands. Isolated, weak to moderate tornadoes are possible from southeastern Texas through southern Louisiana and into southern Mississippi through Wednesday evening. These are not the long-track violent tornadoes of a classic plains outbreak, but a brief tornado in the middle of a flooding rainfall event presents a compound hazard. If you are in these coastal areas, have multiple ways to receive warnings tonight. If you are anywhere in the floodwatch zone right now, what does it look like outside your window? Drop your city in the comments below. I want to know where Arthur is hitting hardest. Now let us pull the camera back and look at what the next 7 days bring beyond Arthur's direct impacts. Thursday, June 18th. Arthur dissipates as a named tropical system, but its massive moisture field does not vanish with the name. The Weather Prediction Center maintains excessive rainfall alerts for the lower Mississippi River Valley through Thursday evening. Heavy rain continues across Louisiana, southern Mississippi, and into Alabama and western Georgia. The flash flood threat remains active across much of the southeast as the tropical plume gets absorbed into the broader frontal pattern. Meanwhile, and this is the part that most regional coverage will miss, the moisture from Arthur feeds a severe thunderstorm outbreak across the Midwest. Illinois and Indiana are flagged for an outbreak of severe thunderstorms on Thursday, as the tropical moisture rides the frontal boundary northward and interacts with strong mid-level dynamics over the Great Lakes region. Friday, June 19th. The direct coastal flooding threat gradually eases across Texas and Louisiana, but the heavy rain corridor migrates into western Georgia and the Carolinas. Charlotte, Greenville, and Columbia, South Carolina, watch for locally heavy downpours. Simultaneously, a fresh system organizing out of the Pacific Northwest begins dropping into the Central Plains. The Storm Prediction Center will be watching from the Nebraska Panhandle through western Kansas and into Oklahoma for the potential of organized severe weather by Friday afternoon and evening. Large hail and damaging winds are the primary early concerns, but the setup has supercell potential. Saturday, June 20th. The Central Plains severe weather setup sharpens. Southwesterly low-level jet increases across Texas, Oklahoma, and Arkansas, feeding warm, moist air into an already unstable atmosphere. Models are advertising a significant corridor of elevated instability from the central Nebraska Panhandle south through western Kansas and into the Oklahoma Panhandle. Discrete supercells capable of producing significant tornadoes, EF2 or higher, baseball-sized hail, and destructive winds exceeding 70 miles per hour are possible. This is the day I am watching most closely going into the weekend, Sunday, June 21st. The severe weather corridor shifts eastward toward the Midwest and the Great Lakes. Indiana, Ohio, and Michigan come into play. Here is the key context. These states have seen remarkably little severe weather over the past 30 to 40 days. There were essentially no tornado warnings in Indiana through the entire month of May. The severe weather drought in these areas is about to end, and people who have gotten comfortable with quiet skies need to refresh their action plans now. The European model and the GFS show some disagreement on exact timing and storm mode, but the atmospheric ingredients across the Ohio Valley are pointing toward active weather this weekend. Monday and Tuesday, June 22nd and 23rd, a fresh low-pressure system drops out of the Pacific Northwest. The Dakotas and Nebraska return to the severe weather picture. Southwesterly flow increases across the Great Plains. The Storm Prediction Center may be looking at another multi-day organized severe weather event during this window. Based on ensemble trends and the larger pattern I'm about to describe, I think there is a realistic possibility of a tornado outbreak during this period, particularly across the central and northern plains. I want to be clear, 8 days is outside the confident forecast range. Things will change. But multiple ensemble suites are pointing at this window, and the pattern dynamics support it. Here is where it gets really interesting, and I will show you exactly why in just a moment. Everything I just described, Arthur, the plain supercells, the Midwest outbreak risk, all of it flows from one fundamental shift in the large-scale atmosphere. Understanding it will tell you what the rest of June and July are going to look like for your area. Let us talk big picture. El Nino is here, officially declared. On June 11th, the NOAA Climate Prediction Center issued an El Nino advisory, the first time in approximately 2 years that El Nino conditions have been formally established. The Nino 3.4 index was already approaching +1 as of early June, putting us near moderate El Nino territory. And this is not a weak or fleeting signal. The odds of this El Nino reaching the very strong category, the highest official tier in the classification system, have jumped from 37% to 63% in just the past month. To put that in historical context, very strong El Nino events are responsible for some of the most dramatic weather disruptions in the modern record. Think back to 1997 and 1998. Think about 2015 and 2016. These were events that rearranged the global weather pattern for a year. What does El Nino actually do to the atmosphere? El Nino warms the central and eastern tropical Pacific Ocean dramatically. That warming suppresses the trade winds, shifts the position of the intertropical convergence zone, and fundamentally alters where the jet stream set up across North America. During El Nino, the Pacific jet stream moves southward and extends eastward across the southern United States. That is called a Pacific jet extension. When it's strong, and forecasters are calling this one of the strongest Pacific jet extensions seen in the month of June in recent memory, it creates a persistent storm track that funnels systems from the Pacific directly into the central United States. Every low-pressure system that drops off the Pacific Northwest gets amplified by the jet. Every piece of energy in the mid-levels gets steered into the plains in the Midwest. That is why you are seeing repeated rounds of severe weather. That is why the pattern has been so relentlessly active. El Nino is loading the atmospheric gun week after week. The Eastern Pacific Oscillation is transitioning toward negative territory after this weekend, building what meteorologists call an Alaskan ridge. High pressure strengthens over Alaska and the western US, that keeps the jet stream anchored over the northern part of the country. Cold fronts cycle through the Central Plains and the Great Lakes on a roughly weekly cadence. The North Atlantic Oscillation is heading toward neutral, which prevents the jet from buckling all the way to the south over the eastern seaboard, but keeps a consistent and active storm track locked over the central US. The Arctic Oscillation is running in a neutral configuration, allowing occasional intrusions of cooler Canadian air into the Great Lakes and Midwest without triggering a dramatic late-season cold pattern. What this means for your area in plain terms, if you live between the Dakotas and the Ohio Valley, across Iowa, Illinois, Indiana, Wisconsin, Minnesota, Missouri, Nebraska, and Kansas, your peak severe weather season is not behind you. It is directly in front of you. June, July, and August are the months that historically define this region's severe weather record, and the pattern is aligned for repeated organized threats. The subtropical jet, also energized by El Nino's warm Pacific waters, will pump moisture northward from Mexico into the southern tier of the country, keeping the Gulf Coast and southeast in an active rainfall pattern through much of the summer. That is the same fuel source that made Arthur as moisture-laden as it is today. Most channels are not connecting these dots for you, but understanding that El Nino is simultaneously cranking up the plain severe weather pattern while suppressing the deeper Atlantic tropics. That is the key to understanding this entire summer, and that paradox leads us directly into the final and most important segment of today's video. Before we wrap up, there is one more thing you need to know, and this is the part I've been building toward this entire video. Let me give you the full 2026 Atlantic hurricane season picture. And then let me explain why one sentence from the National Hurricane Center director this morning should stay with you all season long. NOAA's official outlook for the 2026 Atlantic hurricane season, released in May, calls for a 55% probability of a below-normal season. 8 to 14 named storms, 3 to 6 hurricanes, 1 to 3 major hurricanes. Colorado State University updated their forecast on June 10th, reducing it further to 11 named storms, 5 hurricanes, and 2 major hurricanes. That would put total accumulated cyclone energy approximately 40% below the long-term average. The primary driver across all of these forecasts is El Nino. As El Nino strengthens through the summer, it increases vertical wind shear across the tropical Atlantic and the Caribbean, and wind shear is the single most effective suppressor of hurricane development. It tears apart the organized convection that a storm needs to maintain its structure and intensify. The analog years for this El Nino signal are instructive: 1997, 2006, 2009, 2015, 2023. Most of those were quieter Atlantic seasons. Sea surface temperatures in the Atlantic main development region, the broad stretch of ocean from the Lesser Antilles to the coast of Africa, where most major hurricanes are born, are currently running below normal. That is a cold signal in exactly the zone that fuels the most dangerous long-track storms. Saharan dust has been running above normal across the deep Atlantic tropics, further suppressing development potential. The environment right now in the deep Atlantic is genuinely hostile to major hurricane formation. So why am I spending so much time talking about Arthur, a low-end tropical storm barely above the threshold for a named system? Because of what the National Hurricane Center director said this morning, I want to make sure these words land with every person watching this video. He said, and I am paraphrasing directly, "The main threat from Arthur is going to be a prolonged multi-day heavy rainfall event that could produce dangerous to life-threatening flash flooding." And separately, NOAA Director Ken Graham, discussing the seasonal outlook, said, "It only takes one storm to make for a very bad season. Arthur has 45-mile-per-hour winds. It is not on anyone's radar as a significant hurricane. It barely cleared the tropical storm threshold, and it is still producing life-threatening flooding across 7 states. It is generating flood watches that stretch from Houston to Atlanta. It is triggering disaster declarations. It is putting storm surge into coastal communities, and its rainfall, in isolated locations, could approach 20 inches by the time the system fully dissipates. This is the lesson of this storm, and it is the lesson of every early-season Gulf system in an El Nino year. The Gulf waters are warm, above average. That warm water does not care what the seasonal outlook says. Any system that manages to organize over the Gulf gets access to a deep reservoir of moisture and energy. The cross-Central America pathway, Christina's remnant fueling Arthur, is exactly the kind of early-season mechanism that operates even when the deep Atlantic is suppressed. The Gulf and the Western Caribbean remain the vulnerable zones all season long. What does the rest of the season look like for Gulf and Western Caribbean threats? After Arthur dissipates, the shear environment over the Gulf increases as the El Nino ridge builds over Mexico and the Western Gulf. That should quiet things down through late June and much of July. But the Western Caribbean and the Gulf will see periodic windows of reduced shear as the ridge shifts position. And the warm sea surface temperatures in the Gulf are not going anywhere. Every time a shear reduction opens a window, especially from late July onward as El Nino's impact on the Gulf region modulates slightly, the potential for rapid organization over warm water exists. I am not forecasting the next named storm. I am not predicting a Gulf hurricane this season, but I am telling you that the conditions that produced Arthur, the cross-Central America pathway, the warm Gulf, the stalling front, will repeat in some form at other points this season. And when they do, the same lesson applies. It is not the wind you fear. It is the water. The flooding threat from Arthur is what I need you to carry with you, not as fear, as awareness. Flood-related deaths remain the leading cause of weather fatalities in the United States year after year. Not tornadoes, not hurricanes making landfall as Category 4 monsters. Flooding. Because flooding catches people in their cars. Because people drive around barricades. because people underestimate 6 inches of moving water. If you are in the impact zone from Arthur right now, please do not test flooded roads. Please do not assume your neighbourhood is fine because it did not flood last time. Saturated soil means this time is different. Storm drain capacity is already exceeded in many areas. The water has nowhere to go. Move to higher ground if you are in a low-lying area near any waterway tonight. And if you're watching this from outside the impact zone, from the Midwest, from the plains, from the Northeast, pay attention to the pattern I laid out today, because your turn is coming. The severe weather setup for this weekend and next week across the Central Plains is significant. The Ohio Valley outbreak risk is real. El Nino's jet extension is not done cycling through systems. The atmosphere has been loaded, and it is going to keep releasing that energy all summer. Tell me in the comments where you're watching from today, and tell me which part of this forecast concerns you most. Is it Arthur and the flooding risk? The weekend plains setup? The longer-term El Nino pattern? I read every comment and I want to hear from you. If you have not subscribed yet, now is exactly the moment. Click the button, turn on notifications. Arthur is just the first chapter of what is going to be an active and demanding summer across much of this country. I will be here every step of the way, tracking the data and giving you the analysis that helps you stay ahead of what is coming. Tomorrow I will be watching the developing plains severe weather setup very closely, as the system I mentioned for Friday and Saturday begins to clarify. The shear profiles, the instability maps, the low-level jet evolution. I want to walk you through all of it. The setup has real potential, and I'm going to make sure you understand exactly what we are dealing with before it arrives. If you only need the Arthur flooding update and you're already in the impact zone, jump back to the beginning of this video. If you want the full El Nino seasonal breakdown, the middle section is what you need. And if you want to understand why the below-normal hurricane season forecast deserves your respect rather than your relaxation, that final segment was made exactly for you. Now, I want to spend a moment on something that is genuinely underappreciated about events like Arthur, and it connects directly to the El Nino discussion I'm about to walk you through. When a tropical system interacts with a stalled frontal boundary, the way Arthur is doing right now, meteorologists use a specific term for the rainfall behaviour: training. Storm training is exactly what it sounds like. Imagine a train track laid down from the Gulf directly into your neighbourhood. Individual storm cells, each loaded with tropical moisture, line up and follow the exact same path, one after another, for hour after hour. Every cell drops its load over the same area. The ground cannot absorb it fast enough. The drainage cannot carry it away fast enough. The rivers and bayous receive more input than their banks can contain. Training events are responsible for some of the most catastrophic flood disasters in American history, not just from tropical systems but from any scenario where a moisture source is constant and a boundary is stationary. That is the scenario playing out today from southeastern Texas through Louisiana. The Weather Prediction Center specifically flagged the Baton Rouge corridor and the southern half of Mississippi as areas where rainfall rates of 2 to 4 inches per hour are possible in the heaviest training bands. Over a span of 4 to 6 hours, that translates to 8 to 24 inches of water on surfaces that are already saturated. There is a second mechanism layered on top of the training pattern that makes this event particularly dangerous. When tropical moisture is pushed northward by a frontal boundary and collides with cooler, drier air from the north, what forecasters call the warm conveyor belt colliding with the cold conveyor, the uplift is extraordinary. The atmosphere becomes essentially a precipitation machine. Warm, saturated air rises rapidly. Condensation happens at enormous scale. The result is rainfall rates and totals that would be extraordinary, even in a tropical environment, and this is happening in areas where the infrastructure, the drainage systems, and the topography were not designed to handle tropical-level precipitation. This is the meteorological reality behind why the National Hurricane Center director specifically called out the flooding as the primary threat, not the wind, not the storm surge, not even the tornadoes. The rain is the story. The rain is what kills people in events like this. And I want to come back to a number that the research consistently shows. Approximately half of all flood-related deaths in the United States occur in vehicles. People underestimate moving water. They assume a road that is passable at ankle depth is fine to drive through. They are wrong. 6 inches of fast-moving water can knock an adult off their feet. 12 inches of water can float a small vehicle. 2 feet of rushing water can sweep away a large SUV. If you are in the Arthur impact zone tonight and you encounter water across a road, turn around. No destination is worth your life. No shortcut is worth the risk. The flood fatalities that happen in events like this are preventable. Please let them be prevented this time. Now, let us shift our focus and talk about what the data tells us about the broader atmospheric pattern driving both Arthur and the weeks ahead. Because this is where the picture gets genuinely fascinating from a meteorological standpoint, and where El Nino's fingerprints are absolutely everywhere. One more dimension of the El Nino picture that I have not yet fully addressed, and it directly affects your severe weather risk, even if you live far from the Gulf Coast. When El Nino is present and strengthening, it does not just suppress Atlantic hurricanes and energize the Pacific jet. It also alters the behavior of the subtropical jet stream across the southern United States. The subtropical jet becomes more active, more enhanced, and extends further east and north than it does in neutral or La Nina years. This enhanced subtropical jet is what drives the persistent moisture transport from the eastern Pacific and the Gulf into the central and southern US. It is what fueled Arthur's moisture content. It is what will fuel the next Gulf Coast rainfall event, and the one after that. But the subtropical jet also plays a key role in derecho events. A derecho, a widespread, long-lived windstorm associated with a band of rapidly moving showers and thunderstorms, becomes more likely when you have a strong subtropical jet pushing moisture into the central US, and a jet stream pattern that keeps storm systems anchored over the same region for days at a time. Colorado State University and NOAA forecasters have highlighted the corridor from South Dakota through central Kentucky as the most likely derecho corridor this summer of 2026. Iowa, Missouri, Illinois, Indiana, and parts of Minnesota and eastern Nebraska sit squarely in that zone. If you live in these states, a derecho can arrive with very little warning. Winds of 70, 80, even 90 miles per hour over a swath hundreds of miles wide. Power outages lasting days. Structural damage across entire regions. I will be tracking the derecho threat all summer, but I want you to understand today, while we're talking about Arthur's flooding, that the same El Nino pattern that generated this tropical storm is the same pattern that will drive the severe weather threats in the weeks and months ahead. It is all connected, and understanding that connection is what separates viewers who are genuinely prepared from viewers who are caught off guard every time a new threat develops. One final data point I want to leave you with before the outro. The 2015 Atlantic hurricane season is the most direct analog year for what we are experiencing right now. El Nino was strong and developing. NOAA forecast a below normal season. The deep Atlantic tropics were suppressed, and yet, Tropical Storm Bill formed in mid-June. Bill made landfall along Matagorda Island, Texas on June 17, 2015. Today is June 17, 2026. Arthur made landfall along the upper Texas coast on June 17, 2026. Bill produced catastrophic flooding across Texas and Oklahoma. Arthur is producing catastrophic flooding across Texas and Louisiana. I am not suggesting this is fate or coincidence carrying meteorological significance. I am pointing out that the physics of El Nino years consistently creates windows in June for Gulf-threatening systems, even when the deep Atlantic is quiet. And that pattern will repeat. It always does. Stay safe, stay weather aware, and I will see you tomorrow.